Great. Let's now look at the complementary stream to standard out. It's called standard in. Standard in is another stream in which we can communicate between the operating system and your program. Standard in is the input stream for your program. So the input stream between the OS and your program. Just like standard out is the output stream from your program to the OS, standard in is the input stream from the OS to your program. And we can read it using stdout. Now I want to caution you against running a program like this one without giving it some input. Because if you do, it's going to default to the keyboard and it'll look like the program was hanging. What we can do is do some output, and I'll use ls. You can use dir on Windows, and I'll run it into my program. Now what I'm doing now is piping. You remember piping from the previous video. Piping means that the standard out of a particular program, of the first program, will be piped into the standard in of another program. In this case, our Python program, and you can see what we're doing here. We are reading from standard in and printing the result. So what we'll see is actually no different from what we would have seen if we were to just run ls on its own. So it should be interesting then to try to read it in a more standard way. And I hope you notice that the read method, the read function here, is the same name as the read method that we had for the file handle. That's not by accident. In fact, the other two options for reading are available as well. Read, read lines, or for looping. Here we're doing for looping, so we may as well change this comment. You can do read, read lines, or for looping. And what I'm going to do right now is I'm going to go ahead again and pipe the output of ls to my program, and it's going to read it from standard in, and it's going to read it line by line. In fact, what it does then is it reads it line by line and prints it with a triple star in front of it. In fact, we could go ahead and maybe change the line ending so that there's no line ending, so we can see regular output like that. Of course, the reason we saw a blank line there was because the line itself has a new line in the output, and the print statement adds a new line as well. So I'm just removing it here. Actually, you may notice that this is really no different than any other kind of file reading that we've done in the past. I might use the regular idioms that we've been using before with files. For example, rstrip. I'm just putting stars in front of my output just to give you a sense of what's possible when you're reading from standard in. You could write it to a file. You could add line numbers. It'd be quite easy for me to just add a line number. Using the plus equals operator, which I've never really used before, in order to give us a nice line that increments. I would probably use the format method, but I'm having a little fun here. Oops. Oh, of course, I need to use stir, so I should probably have used the format method, but whatever. And there we go. You can see I'm taking my output and just adding a line number. Why not? Whatever it is I want to direct into my program, that can easily be processed then at that point, which is kind of interesting because it means that we don't necessarily have to save and then reopen data that might be generated at the command line in order to use it in our Python program. We can simply read it directly from a redirected stream. Speaking of which, another way to redirect into a program is to use the less than sign. Here's out.txt that I wrote earlier, and we can see out.txt this way. you may remember it's very similar to the greater than sign. We were using the greater than sign to write from our standard out into a file. Here, we're using the less than sign to read from a file into our standard in. So these are two options for reading into standard in. Now you may want to know, what is the purpose of all this? Why do we need standard in and standard out? Well, first, our primary goal is just to make you realize that when we're outputting, we have the option to do various things at the command line because we're not printing directly to the screen. We're printing to the operating system through a special stream called standard out. And at the command line, you have options for how you want to handle that. For instance, you may want to write to a file, but you may not want to have to handle the file name inside the program. You can use the greater than sign. You may want to read from a file, but you may not want to have to handle that inside your program. You can use the less than sign. And if we're working with other programs, other scripts, then we may want to do that because we maybe want to make our program flexible enough to be able to handle files redirection or possibly even program output redirection or piping, I should call it. For example, as it might be obvious by now, if one Python program outputs standard out and we know we can pipe, we should be able to output from one Python program to another. Now, I don't have a specific application for you for this. I do want to make you aware of it because every good IT professional needs to become conversant and capable on the command line. And so these are the very small ways that we can begin our understanding of working at the command line, using command line utilities and allowing our Python programs to work alongside of other programs at the command line.